One of the interesting applications of Sphinx is to help augment factor models or to help people validate and test out new factors. We'll do a rudimentary example of this here. We obviously don't run a factor model at Sphinx, but we can do is show how we can understand relationships between different companies and use that to make models that jointly predict or help understand the joint distribution of returns between multiple companies. So what I'll do here is I'll say that I have a universe of tickers of interest, which is in some CSV file, ticker universe.csv. And I want Sphinx to do the following. First, look at a English language description of what each company does and go embed that. And then tell me if companies with similar embeddings, if the embeddings exist at similar spaces, tend to have similar returns profiles over the last 4 years. So we'll toss this to Sphinx, let it get to work, activate its kernel, and start interacting with the code. It'll start, of course, by just confirming that all the data I claimed existed does indeed exist, and we'll start loading it. And of course, we can see we have tickers and then some descriptions. What we can showcase here is Sphinx's ability to leverage smaller models under the hood. So here Sphinx will call in an embedding model, and in a couple of seconds, it's able to go and embed these hundreds of companies in my universe of coverage, embed the descriptions, and now we have these vectors that we can use to go and start building out our model. So we'll go fetch returns for these companies. Obviously, there's 100 of them or so, and we are going to use a free API from Yahoo Finance to do so. I'll go start pulling the data. Seems like maybe some of them don't actually exist, and that request may not succeed. Indeed, it didn't. And now we'll go and see if we can calculate some kind of returns correlation. Well, first it has to actually calculate returns, so it's going to go do that transformation and then go find if, in this case, LLM embedding similarity predicts return similarity. So we have a point for each pair of companies here. And the correlation seems actually quite weak here. There are some nans that may be causing some issues. So Sphinx is going to find the nans, fix them, remove them, etc. And having removed the nans, we find that, yeah, like the correlation is not entirely strong here. Maybe some of the outliers on the top right actually do have some shape that's relevant. For all we know, that could be the AI companies, and we could go inspect that with Sphinx. But instead, what I'll do is I'll say, actually, let's try a more traditional approach to these factors. So instead of just doing this generic scatter plot, let's make clusters in the embedding space. And of course, this has been validated by lots of research that this kind of thing does work. But we'll see, can we use cluster membership as a factor? Now, obviously, Sphinx will not have any other factors to compare this to, as if it's an incremental add on top of other factors that you may already be using. But if you do tell Sphinx that context, it obviously can do that. It'll go embed these factors and then go and look if, it seems like what it's trying to do is see, okay, if correlations of returns within a cluster are stronger than cross-cluster correlations. It's running into some issues with indexing, totally fine. It'll go solve its own problems. And this is typically where data scientists waste a lot of time, and we'll just do that for you. Obviously there's one on-diagonal element that seems quite a bit larger than the others, but generally it seems like the on-diagonal elements are around 30 to 40%, whereas the off-diagonal elements are around 20% correlation. Obviously, all returns are reasonably correlated because we don't have anything that we're orthogonalizing out. But in and of itself, this is a reasonably interesting result, and we could certainly pair this with your factor model. We could pair this with other hypotheses, for example, around why companies may be related, for example, an analyst coverage graph. We could also leverage other models, graphical models, etc., in order to robustify this analysis. But just to wrap up, I'll have Sphinx go and plot this equal weight daily means returns per cluster, and also go use an LLM to name it from a presentation perspective. Of course, there is some global correlation for these names from the market, but we do see that there is some structure that we might be able to exploit even from this very simple example.